Hi, my name is Shaolin Ruan, and I will present our recent work, Intercept Graph, an interactive video visualization for comparison of state changes. This work is done in collaboration with Yong Wang from Singapore Management University and Qiang Guan from Kent State University. As we all know, state change comparison is one of the most commonly needs of quantitative analysis, and it is often necessary in multiple application domains, such as medical science, financial engineering, sociology, and biological science. Visualization has been proved a powerful tool for data exploration, but there is still no specific visual design for the data type of state changes across a set of items. Existing tools, for example, the grouped bar chart, can be used to present state changes, but several limitations still exist, which affects the user's graphical perception. And that's why we introduce our novel visual design, Intercept Graph. First of all, I would like to briefly introduce its design. As shown by the title of our paper, Intercept Graph is a novel visualization to support interactive comparison of state changes. Our design has several advantages than existing techniques. First is a context-aware visualization. Context-aware means that our design could visualize the change quantity by reflecting the before and after states. As shown here, the inner and outer circular axes are used to visualize the value of context states before and after respectively. Second, it encodes the state change dimension by an effective visual element, the line segment length. In this example, the line in dark blue means that the value of its item is rising from 65 to 96, and its change quantity is larger than the line in light blue, because the line segment length of the one in dark blue is longer than that of the item in light blue. Please note that our design consists of two semicircles, which are used to separate items with rising and dropping trends. Thirdly, the outer circular axis is fixed, but the inner circular axis is adjustable, which supports the user interaction via controlling the radius of the inner circular axis. Through adjusting the inner circular axis, the arrangement of all lines changes accordingly. Next, I will show you the two widely used visualizations for state change comparison. According to our preliminary survey, there are two visual designs for plotting state changes. As shown here, two figures are visual metaphors encoding the same data. The left diagram is grouped bar chart, and the right one is a slope graph. Grouped bar chart encodes the initial and final values by respective categorical bars within each group, and the bar height differences are used to representing change counts. And the slope graph uses line slopes to display change counts. But why do we introduce our design to reflect state changes instead of these two widely used visualization tools? According to our case study, we found that Intercept Graph has two primary advantages over the preceding designs. For example, the NBA League evaluates all players and would select the player with the biggest progress and give him an NBA MIP award annually. As you can see, these two figures both visualize PPG changes of over 300 players in the NBA League. However, the methods here suffer from the visual clutter significantly. For example, can you select the players with the largest PPG changes or top 5 PPG changes from these two figures? It seems impossible, right? In fact, even though in the regular item number, it is still difficult to filter those items due to their ineffective encoding ways. Our visual design Intercept Graph can address this challenge through smooth filtering. For example, if we set a number to 30, the inner circular axis would shrink inward to filter out other players with relatively smaller PPG changes and accentuate 30 players with large PPG progress. At the beginning, the figure doesn't filter anything because the inner and outer circular axes coincide, and then lines with bold segments within the inner circular axis are the players we are looking for. As the inner circular axis shrinks inward, the goal items are accentuated within the inner circular axis. Besides, what if the change quantities are close between two items? Let's do a test. Can you accurately tell which item has a larger state change for rising and dropping datasets respectively via grouped bar chart on the left? It's not easy, right? Because grouped bar chart uses height differences to present changes, which are proved to be difficult for viewers to compare. And what about a slope graph? It sounds good, but the slopes are not the appropriate solution as well when two change quantities are rather close, as shown in the figure on the right. Our visual design solves this issue by the inner circular axis interaction. We found that intercept graph can magnify the differences of two state changes and makes them more intuitive to be compared. The user can adjust the inner circular axis freely until the relationship of changes is apparent enough to be determined. As you can see, it's way more obvious compared to the preceding ways. At last, I will present the key of our design, the user interaction. We introduced two approaches to support the interaction. The one is a free exploration via a control slider to change the arrangement of all lines. The second method is the interaction with an input form. The user types in the number of items filtered, and the processing module would work out the inner circular axis to meet the requirements. Instead of calculating if each line has an intercepted line segment of non-zero length within the inner semicircle, we adopt another load-savvy trigonometric formula. Because if we intend to filter top k items from intercept graph, the line denoting the k+1 largest change item and the inner circular axis are tangent when the line and the inner circular axis have only one intersection point. In conclusion, our research work can be summarized into the following points. Intercept graph is a novel context-aware visualization for comparison of state changes. It supports the smooth filtering of items with large state changes and enhances the comparison of items with similar state changes interactively. That's all about our novel context-aware visual design intercept graph. So thanks for your attention, and I'm waiting for your questions.